All right, so the lesson we've got today, end of the lesson, is going to be lesson 6, similarity transformations. Okay? Nothing too crazy with it. Actually, I'm going to kind of simplify it down from where it could be. But the stuff you'll be able to do, you'll be able to identify those transformations. And then we'll kind of verify the similarity, which, again, seems weird, but it'll all make sense in a second. All right. So the big definition that you guys are going to see is this one right here where it says dilation. Have you ever heard the word dilated before? What did it refer to? Your eyes, yeah. What's it mean like when your eyes get dilated? Yeah, the pupil gets bigger. The pupil's going to get bigger or it can get smaller depending on if it's really bright outside. But you guys have already, hopefully, heard that word before. So dilation means that something either is going to be getting bigger or it's going to be getting smaller. So in math class, in geometry, this dilation refers to the transformation that enlarges or reduces the original figure. Is it getting bigger? Is it getting smaller? Okay? So of those dilations, you've got two types, and I'm going to explain what this means in a second. Or not really in a second, right here. The first one is going to be an enlargement. So for this example, just to kind of show you what's going on, you don't have to worry about these extra lines if that's too confusing. But my blue shape is going to be what it starts off as. So my blue shape is going to be here, and my green shape is the new one. As you can see from the blue shape to this one, it's getting bigger. Okay? So if it's getting bigger, think like Alice in Wonderland, it's enlarging. Okay, it's getting bigger. So when we start talking about this, when it's growing, it means the scale factor. You're going to multiply it by a number that is bigger than 1. Okay, it's getting however many times bigger. That's what the enlargement is. Okay, if you have a reduction, so again, we're starting at blue and we're going to green. If you have a reduction, it means it's getting smaller. Okay, when we start talking about what we can multiply it by, it's going to be a number that is smaller than 1. So like it's 50% as big, or it's 20% as big. The one thing I'm going to make sure that I stress for reduction, at no point can you ever go negative. Okay, we'll never have a negative number, ever. Because then it would disappear and it'd be imaginary. Okay, the nice part about this geometry stuff is that it's stuff that you can see and touch if it were an actual shape. We're not dealing with imaginary stuff. So if it's an enlargement, it's getting bigger. If it's a reduction, it is getting smaller. And with the reduction, and I'm going to write this, I'm going to say never smaller than 0. So never going to be smaller than 0. Okay. So on these ones, the stuff we're doing, I'm going to let you know it's going to start off, it's going to say from A to B, so shape A, and we're changing it to B. We have to first figure out if it's going to be enlarged or it's going to be reduced. All right, so looking at this one, I'm going from A to B. A is this shape, B is this shape. Is it being enlarged or is it being reduced? How about this? Is it bigger or smaller? It's smaller. So if it's smaller, it means it's a reduction. So smaller means it's a reduction. Okay, I'm not going to have you go crazy with having to count, like use the distance formula for this stuff, which is why this lesson is going to be a lot shorter. But looking at this one, if it's across those straight lines in the bottom, that's where I can kind of figure it out. So looking at shape A, I can choose whichever side I want. My suggestion is to go with the side that's perfectly straight, so I just have to count the boxes. Don't do one of these diagonal ones. It'll still work the same, but it's a lot more work. So I'm just going to do the bottom of these ones. Okay, for shape A, how many spots is it going across? All right, so I've got one box, 2 boxes, 3 boxes. The length of this is going to be 3. Okay? The length of B is going to be 1. Make sense so far? I'm just counting this one. If I want to count the side ones, I'll do that. I'll actually do it again with another color. Okay? So it is, I'm gonna write it out this way. It's starting at this, it's starting at a 3, and it's turning into a 1. So for me to figure out what that reduction is, I'm going to look at this number, I'm going to look at this number. So what it ends up as, I'm going to divide by what it started as. So it ends up at a 1, and I'm going to divide what it starts at. So I'm going to actually write that thing out because it will work out this way every time. So where it ends, I'm going to say it ends up over how it starts. So it ends at a 1, it starts at a 3. I've got 1 divided by 3. So if I take 1 divided by 3, what is 1 divided by 3?
0.3 repeating.
Perfect. 0.33 repeating. Okay? So that's what the division is. How do I change a decimal into a percentage? You just move that decimal place over 2 spots. So this is, I'm going to kind of put a little box around this. That's the reduction. So if I multiplied it by 0.33, that's kind of how it would change. Or I could say it is a 33% reduction. Because again, I take this number and I just move that decimal place over 2 spots. So my scale factor is 0.33, or if it's asking for a percentage, it'd be 33%. I told you I was going to do this with the other side, so I will do it with a different color. If I were to count this side, I've got 1, 2, 3, 4, 5, 6. So the length of this one is 6. This one is 2. So I'm going to have where it ends up at a 2. It starts at a 6. If I did 2 divided by 6, my answer is 0.33. Again, I can choose either one, but my fraction, whenever I set it up, just to really simplify it, will be that it ends up over what it starts as. You know it was a reduction, so it had to be smaller than 1. Example number 2. I'll get a different color. So look, I'm going to zoom in as best I can so you can really see this. Bless you. Okay, looking at these shapes, it starts as an A, and it turns into a B. Is that getting smaller or bigger? It's getting bigger, yeah. So I know it's getting bigger. So it's an enlargement. All right, now looking at the sides of this shape, which side do you want to use to count? I'm going to point to it, you just tell me yes or no. You're shaking your head no, I agree. No? Yes, because there's kind of really easy blocks that I can do. I don't have to use a distance formula. I don't have to put them into y sub 2 minus y sub 1, all that fun stuff. I can just go straight through and I can count that one up. So for A, it's got 1, 2, 3, 4. The height of A is going to be 4. And the height of B is 1, 2, 3, 4, 5. That one will be a height of 5. Exact same order. Kind of sort through. I'll give myself a little bit extra room. So the way I set it up is no matter what on top, what it ends up as, over what it starts as. So what number does it end up as?
5.
Perfect. What number does it start as?
4.
Perfect. 5 divided by 4, put it on my calculator, I get 1.25. So the scale factor is 1.25. Or I could say is a 125% enlargement. Really, this assignment is worried most about the scale factor, but the next one we do is going to be dealing with scale models using kind of those percentages. So that's why I'm kind of showing both at once. How you guys feeling with that? Okay, I'm going to have you guys try one all on your own. It's starting with A, and then it's going to B. Either one. You either count the bottoms, and then compare to the other bottom, or you can count the side, and then compare to the other side.
So it would be, if we were doing the bottom, 23, 2, and 6.
Yep, but which one's the top one? Whatever it comes out with.
Like which one?
Yeah, the fraction. Yes.
B.
Yes. So you don't do right. Maybe 2 and 6. Yep. Awesome. Okay, I'm gonna write down. So first and foremost, is this an enlargement or reduction? Enlargement. Love it. Gents? Okay, what is my fraction gonna be? Or what's my scale that's gonna go up? So you put 6 over 2, which simplified down to 3 times enlargement. Or I could say, a 300% enlarge. So 3 times 3 scale factor. Scale factor of 3 or a 300% enlargement. You guys feeling good? Yeah. Last one, show me what you can do. Again, either way will work out. A is what it's starting as. B is how it's ending. I'll give you 1 minute.
I have a question.
Yes, ma'am.
So basically, will B always be on top?
Yes. Whatever ends as will be on top. Will be on top. Yeah, the entire lesson there needs to be as well.
Okay.
Yep. So it'd be 0.5 or 50%.
When you not count the square? When it gets 2%.
To the very, very end. So the very tip. So we either counting this spot here or this spot here.
So for B, would it be 3?
Yes.
Okay.
Oh, I counted.
I'm sorry. Well, I was just pissed off because we're doing so well. We should show off. So he's like, yeah. Okay, but this actor is so different. And church is water. Are you fine? I was actually so mad. Like, Snapchat.
All right. So for this one, from A to B, is it an enlargement or reduction? Reduction. And what's the scale factor? Perfect. Scale factor is 0.5. If I was going to do a percentage, it would be a 50% reduction. Okay, my scale factor is going to be 0.5. You should have had either 3/6, or you would have had 2/4. Didn't matter which side you went with. If you decided to go for the diagonals, it would be 5/10. Because you'd have to do the distance formula for all those. Shape's good. Okay, the very last one is just going to be using a scale factor to kind of solve a story problem. And this one seems scary. Not bad at all. It says a photocopy of a receipt is 1.5 inches wide and 4 inches long. So I'm going to make myself a nice little shape that I can just visually see. It is 1.5 inches wide, 4 inches long. By what percent should the receipt be enlarged so that the image is 2 times the original? What are the dimensions? I'm going to take whatever these numbers are, and it's saying it's going to be 2 times as big. I multiply by 2. So what would the new receipt dimensions be? 3 and 8. I'm going to take 1.5 times 2, and then 4 times 2. Again, if they give you a story problem and they tell you the shape, my suggestion is just draw it out so you can visually see it. But they will tell you it's 2 times the original, it's 0.5 times the original. It will give you the scale factor. All you're going to do is just multiply by whatever that scale factor is. Questions on the story problem? Sweet. We're not doing those. Or this. Here's what you got. (614), 6 through 11, all. You have 6 more problems. And then you are done. With like 12 minutes to go.